ডিয়ার স্টুডেন্টস, ওয়েলকাম টু প্রোঅ্যাক্টিভ এডুকেয়ার। তোমরা সবাই অলরেডি RRB ALP টেকনিশিয়ান তার ফার্স্ট স্টেজ CBT মোড এক্সাম হয়ে গেছে। এখন নেক্সট সেকেন্ড স্টেজ CBT মোডের সিলেবাস এবং তার এক্সাম প্যাটার্ন বা কোশ্চেন্স প্যাটার্ন সেটা অলরেডি তোমরা RRBর অফিসিয়াল ওয়েবসাইটে পেয়ে যাবে। কিন্তু আজকের যেটা ব্যাপার সেটা হচ্ছে যে কোন কোন জায়গাগুলো, কোন কোন টপিকগুলো ইঞ্জিনিয়ারিং অ্যান্ড বেসিক সায়েন্স, দ্যাট ইজ ফিজিক্স ওরিয়েন্টেড, কোন জায়গাগুলোকে ফোকাস করতে হবে সেটা আমাদের খুব ভীষণ ইম্পর্ট্যান্ট একটা ফ্যাক্টর। কারণ তুমি যদি স্টেজ 2তে বেসিক সায়েন্স অ্যান্ড ইঞ্জিনিয়ারিংয়ের উপর ভালো স্কোর করতে না পারো তাহলে কম্পিটিশনের অনেকটাই বাইরে চলে যাবে। এখন এই জায়গাটা ফিজিক্স ওরিয়েন্টেড জায়গা, সো নর্মাল যারা সায়েন্স ব্যাকগ্রাউন্ডের স্টুডেন্ট তারা অলরেডি সবই পড়ে এসছো, কিন্তু সেগুলো একটুখানি প্র্যাকটিসের মধ্যে না রাখলে সেগুলো কিন্তু এক্সাম সেন্টারে গিয়ে ট্যাকেল করতে কিন্তু অসুবিধা হবে। সো আজকে কিছু কিছু পোর্শন ফিজিক্সের আমি ডিটেলড এক্সপ্লানেশন এবং তার সমস্ত কোশ্চেন্স, সেখান থেকে কী ধরনের কোশ্চেন্স হতে পারে তার একটা পিকচারাইজেশন আমি করে দিচ্ছি। তোমরা ভিডিওটা ফলো করো। আজকে যে টপিক ফার্স্টই সেটা হচ্ছে ওয়ার্ক পাওয়ার অ্যান্ড এনার্জি। ওয়ার্ক পাওয়ার অ্যান্ড এনার্জি বেসিক সায়েন্সে এটা একটা ভীষণ ইম্পর্ট্যান্ট চ্যাপ্টার, ওয়ার্ক পাওয়ার এনার্জি। সো এই ওয়ার্ক পাওয়ার এনার্জি ভীষণ একটা ইম্পর্ট্যান্ট চ্যাপ্টার। সেটা কি, হোয়াট ইজ ওয়ার্ক? তো ওয়ার্ক, ফার্স্টেই ওয়ার্ক ইজ এ স্কেলার কোয়ান্টিটি, ইট ইজ এ স্কেলার। হোয়াই স্কেলার? বিকজ ওয়ার্ক হ্যাজ অনলি ম্যাগনিটিউড, দ্যাট ইজ শুধুমাত্র ভ্যালু আছে বা মান আছে, যে কতটা ওয়ার্ক ডান তুমি করেছো সেটা তুমি বলতে পারবে, কিন্তু ঠিক কোন ডাইরেকশন বা ডাইরেকশন ইজ নট নেসেসারি টু ডিফাইন ওয়ার্ক। সো ওয়ার্ক ইজ a scalar quantity, it is not a vector, because vector quantity, if it vector quantity, to define a vector, magnitude as well as direction both are necessary, magnitude and direction, magnitude as well as direction both are necessary, but for scalar only magnitude, that is value. So how we define work? Work is force into displacement, force into displacement, displacement, force into displacement. When a body is subjected to a force F, and if it is acted upon by the force, the displacement of the body is, now the body is displaced by the final point to final point. So displacement of the body is S. Now force has both magnitude and direction, so it is a vector, and displacement also has magnitude and direction, so it is also a vector. So work done equal to force dot S, that is W equal to F dot S. Work done equal to force into displacement. Actually force into displacement here, actually in vector notation it is the dot product of F and S, that is force and displacement এর dot product হলেই কিন্তু আমরা work done কে পাচ্ছি। So work done equal to force into displacement. Why? Because every time the direction of force and direction of displacement এটা যে সেম হবেই তার কোনো মানে কিন্তু নেই। ধরো তুমি বডিটাকে ফোর্স দিচ্ছ এইভাবে, তার ডিসপ্লেসমেন্ট হচ্ছে, তার ডিসপ্লেসমেন্টের ডাইরেকশন, তার ডিসপ্লেসমেন্ট হচ্ছে ধরো এইভাবে, তাহলে তখন সেই ইন দ্যাট কেস এফ অ্যান্ড এস হ্যাজ টু ডাইরেকশন, সো উই হ্যাভ টু ক্যালকুলেট দ্য ওয়ার্ক ডান along the direction of displacement, because পয়েন্ট অফ অ্যাপ্লিকেশন অফ ফোর্স, সেটা যেদিকে ডাইরেকশনে যা তার ডিসপ্লেসমেন্ট সেই ডাইরেকশনে ফোর্সের কম্পোনেন্টটা কি, হোয়াট ইজ দ্য কম্পোনেন্ট অফ ফোর্স ইন দ্য ডাইরেকশন অফ এস, দ্যাট ইজ ইট ইজ, if it is theta then it is f cos theta. So work done equal to f cos theta into s. Here f cos theta is the component of the force along the direction of displacement. So f s cos theta, that is f dot s. It is the definition of work done. That is, work is a scalar quantity and it is the product of displacement and the work equal to force along the displacement into magnitude of displacement, that is displacement. So we have defined work done, that the component of force in the direction of the displacement into magnitude of displacement, that is W equal to f s cos theta. So now when theta is 90 degree, that is f in this direction and s is perpendicular to it, so theta equal to 90 degree. Now we know that if we put the value of theta in that equation, cos 90 value, cos 90 equal to 0, so W equal to 0, and in that case the force is called as no work force, because in this case work done is 0. Again, if force is in this direction but displacement is 180 degree to the direction of force, so cos 180 degree value minus 1, cos 180 degree value minus 1, so in that case W equal to minus fs, that is negative work done. So negative work done when force is acted upon in such a direction which is opposite to the displacement of the particle or body or substance. So work should be positive or negative. It may be also 0. So work has only the value or magnitude, either it is positive or negative or 0, so it is a scalar only. It does not depend upon the direction. So to define work, direction is not necessary, so work is a scalar. Whereas force and displacement, by work is the product of force and displacement, both are vector quantity. But when we perform the scalar product or dot product between two vectors, it gives always a scalar quantity, and that's why dot product is also called as scalar product. Now positive work done when f and s is in same direction, that is theta equal to 0 degree, so cos 0 value 1, and that in that case W equal to fs. So it is a special case, W equal to fs. Force into displacement, it is a special case, that is in this sense it is positive work done. When we pull the bucket from the well, then the acceleration, then the gravitational force acted on the bucket towards the center of the earth, that is downwards, but the displacement of the bucket is upward. It is a well, and when a bucket that is gravitational force is downward but displacement is upward, and in that case the work done by the gravitational force on the bucket is negative, but the work done by the force of the man by which it pulls the bucket upwards, it is positive, because the man acted upon by the force, that is tension in the rope of the bucket by which it is attached, and so due to f of man the work done is positive, but due to gravitational force, due to the direction is opposite to the displacement, and that's why due to gravitational force the work done is negative. So in this context we have again already what is positive work done, what is negative work done, and what is zero work done, that is no work force. So now the case of no work force, when when electron revolving around the nucleus, the centripetal force towards the center acts toward the center by which it revolves around the nucleus, and the necessary centripetal force is supplied by the Coulomb's attractional force, that is electrostatic force of attraction between the nucleus and the electron. And now the instantaneous displacement or instantaneous direction of its displacement is 90 degree towards the force of centripetal Fc. So centripetal force and displacement here 90 degree in direction, so no work is done in this case. Similarly, solar system, when planets are revolving around the sun, there is no work done, because if we consider the circular path of the circular orbit, so no work done, that is centripetal force is a no work force. Centripetal force is a no work force. When a particle is subjected to a circular path and moving along a circular path by a string, attached to a string, then the centripetal force towards the center and its displacement S is 90 degree to the centripetal force. So it is also a case of no work force. Again, W equal to Fs cos theta. So work is 0 when theta is 90 degree because of cos 90 factor. But if S is 0, S is subject to 0, that is F is present but S is 0, then also W is 0. So in that case also no work force is defined. And in this case the example is when a wall is subjected to a force but its displacement is 0, then the force is a no work force and the work done is 0 work done. Now SI unit of work is joule. SI unit of work is joule and CGS unit of work is arc. So work is a scalar. What is its dimension? Work equal to force into displacement. Force into displacement. Now force, dimension of force is ml t to the power minus 2 and displacement, that is L. So work, dimension of work is ml square t to the power minus 2. So work is a scalar and its dimension. So unit of work m, that is mass said unit of mass is kg, L that is length, that is meter square, t time, that is second to the power minus 2, that is second square inverse. So kg meter square per second square. It is the SI unit of work done and it is called as joule. So what is 1 joule work? When 1 kg, the mass of 1 kg is displaced by 1 meter in 1 second. Then it is called as 1 joule work. That is again in another word, kg meter, it is written as kg meter per second. Kg meter per second, kg into meter per second square, that is into meter. So kg meter per second square, that is Newton, because force ka unit Newton, SI unit. What is kg meter? 1 Newton, that is 1 kg per meter per second square into meter, Newton meter. So 1 joule equal to 1 Newton meter. 1 joule equal to 1 Newton meter. So when 1 Newton force is applied on a body and if it is its displacement is 1 meter along the direction of force, then we say that the work done, the value of work done is 1 joule. So it is the magnitude of work done, 1 joule. So it has only magnitude, so it is a scalar. So joule is the SI unit of work done and CGS unit of work done is arc. So 1 joule equal to 10 to the power 7 arc. It is a very, very important relation. 1 joule equal to 10 to the power 7 arc. Now work done. Now the concept of work done in case of rectangular components. So now W equal to F dot S. So F, that is I hat Fx plus J hat Fy plus K hat Fz, where I hat, J hat and K hat, these are the unit vector along x axis, y axis and z axis, and Fx, Fy and Fz are the components of force along the x, y and z axis respectively. And again the vector, the components of the vector S, that is I hat Sx plus J hat Sy plus K hat Sz. Now I dot I is 1, J dot J equal to 1 and K dot K equal to 1, and I dot J and I dot K is 0, J dot I and J dot K is 0, and K dot I and K dot J is 0. So by performing the dot product of this expression, we have Fx Sx plus Fy Sy plus Fz Sz. So it is the value of work. So you have to know the rectangular Cartesian coordinates relation of work done, and it is very, very important for basic science and engineering. Unit of work, SI unit, dimension already has known. Now work done in pulling and pushing an object. Work done in pushing and pulling an object. This is a very, very important relation, and from this mathematics have also important portion. So work done in pulling and pushing an object. Work done in pulling and pushing, push and pull type of an object. So this equation is F equal to mu mg, force equal to F equal to mu mg by cos theta plus mu sin theta, cos theta plus mu sin theta. This is a very, very important relation, where mu is the coefficient of friction, where mu is the coefficient of friction, m is the mass, g is the acceleration due to gravity, and theta is the angle between the horizontal and the direction of force. So force required to pull an object is mu mg cos theta plus mu sin theta. This equation is very, very important. And now work done equal to W equal to, we know that W equal to Fs, and so it is mu mgs by cos theta plus mu sin theta. So it is a very, very important relation, mu mgs into cos theta plus mu sin theta. Similarly, work done by variable force, if it is pulling an object, but similarly work done in pushing an object, only this sign is minus, that is mu mg cos theta minus mu sin theta, that is pushing, and plus this is pulling. So in this context we say that when pulling an object, the work done is smaller than the pushing of an object, because when it is minus, then the numerator denominator is lesser than the former case, that is when it is plus. And so pulling an object, for pulling an object, F is smaller. So pulling is easier than pushing. Pulling is easier than pushing. Pulling is easier than pushing. So it is a very, very important concept. Now work done by variable force. The work done by variable force, variable because what is variable force? Because the magnitude of the force is not, variable force means the magnitude of the force is not constant over the period of time. Magnitude of force is not constant. And so what is variable force? So variable, according to the variable force, work done equal to x1 to x2 f dx. That is integration over x1 to x2 f dx, where f dx is to area under fx curve with proper algebraic sign. So f dx, that is integration over x1 to x2. So work done by variable force, that is f is not constant, and that's why integration is over over the f. So w equal to x1 to x2 f dx. This is a very, very important relation. And now again, work done in small displacement dx, dw equal to f dx. So that is x1 to x2 f dx, that is dw. And now we have to know that what is f dx. So f dx, it is we know that f dx, that is equal to k x1 to x2 x dx, because here that is minus k, because f equal to minus kx, where k is the spring constant. So if when we put f equal to minus kx, so minus k x1 to x2 x dx. And that's why we have to know that x dx, that is minus k integration over x dx, that is x square by 2, that is x1 to x2, that is half of k into x2 square minus x1 square, half of k, that is x2 square minus x1 square, that is the w. So it is a very, very important relation. And you have to know that what is the actual syllabus of basic science and engineering. Actual syllabus maintained HS 10+2 level, but it is MCQ pattern. So you have to know this. And also the trade syllabus, that is the part B of the stage 2 exam, there is also some 10+2 level mathematics, that is physics portion, that is integration, differentiation, the formula is necessary of every integration differentiation formula, that is sin x, tan x, cos x, and integration formula and differentiation formula is necessary in that concept, because from this portion mathematics also has come. So this is the equation. Now what is conservative force and non-conservative force? Force are two types, conservative and non-conservative and conservative. Non-conservative, conservative force. What is conservative force? Conservative force is said to, when a force is said to be conservative, if the work done by or against, by the force or against the force, is independent of path and depends only on initial and final positions. That is, here a body is initially and then by the force it is final position. If we avoid this path and if we taken along this path or along this path, the work done in every case is same. And so at that case, particular case, the force is said to be conservative, because it does not depend along the direction of path or along the position of path or length of path. It is only depends upon the initial and final position. So path is not important here. On which path it in the particle or substance or body be subjected from or be displaced from initial to final position. And number 2, the force does not depend on the nature of path followed between the initial and the final position. Conservative force is that force, and any conservative force always be expressed by the F equal to minus grad phi. That is the F is always expressed, conservative force is always expressed the gradient of any scalar. This is a scalar field and it is a vector field. So gradient of any scalar, it is expressed, and that is, it is conservative. Which forces are conservative? That is gravitational force, elastic force, restoring force, gravitational electrostatic force. The example of conservative force are very important. Electrostatic force, gravitational force, elastic force, restoring force, and force due to spring, that is restoring force due to spring. These all are conservative in nature. But what are non-conservative forces? So non-conservative forces are those forces for which the work done depends upon the path between the initial and final position. That is, which path is chosen in that case. It does not depend only on the position of initial and final position. Non-conservative force are naturally they are resistive in nature. That is resistive. That is they are air resistance or viscous force or viscous drag force. That is viscosity arises. So non-conservative force, due to non-conservative force, non-conservative forces are not represented by the gradient of any scalar, and that's why conservative force, the curl of conservative force is always 0. But for non-conservative, that is conservative, and non-conservative, the curl of non-conservative force is not equal to 0. But this is always a 0. This is always 0. So curl of any conservative force is 0, but non-conservative force is not 0. And work done along a closed path or in a cyclic process is 0 for any conservative force. That is integration closed path integration f dot dx, that is f dx equal to 0. That is এখানে কিন্তু conservative, f conservative, that is cyclic integral f conservative. So conservative force এর জন্য work done কিন্তু along a closed path 0. That is when a particle, if the force is conservative and by the conservative force a particle is moved along this path to f position and again along this path it is finally stopped to the initial position, then the total work done is 0. So along the closed path or cyclic path the work done should be 0. Now energy. What is energy? Energy is the capability of doing work. What is energy? So energy is also a scalar quantity. So energy is basically two type. Kinetic and potential. Kinetic energy is defined as half mv square and potential energy is mgh. So potential energy Pe equal to mgh and Ke equal to kinetic energy equal to half mv square. So what is kinetic energy? Kinetic energy is the energy of a body when it is in motion. That is any body which is in motion, the energy possessed by the body, that is moving body, is kinetic, and v is the velocity of the body, m is the mass of the body. So half mv square. What is the energy? What is the potential energy? Potential energy is the energy of a body due to its configuration of position. When a body is at height h and mm, then its potential energy is mgh, that is mass into acceleration into gravity into h. It is gravitational potential energy. And when a body is subjected to a force and it is curved, that is its configuration or it is deformed, then elastic potential energy stored within it. Elastic potential energy, example of elastic potential energy, that is compressed spring or elongated spring. So when spring is compressed or elongated, it is deformed, and that's why, due to elastic property, elastic potential energy is stored within it, and that's why to elongate or compressed a spring, work is done. And so potential energy, always the work done by the body is stored within when the body is displaced from the ground to that position, some work is done on the body, and the amount of work done is stored within the body as a potential energy. When the body is again free fall by the gravitational force, and then the stored potential energy is converted into kinetic energy according to the principle of conservation of energy. Total energy along this path is always constant. Now kinetic energy and potential energy. So what is the unit of energy? The SI unit of energy is joule, which is same as work done. So joule, SI unit of energy is also joule. Now this is kinetic energy. So here a math is arises that if the mass of a body is 2 kg and its velocity is 5 meter per second, what is its kinetic energy? That is kinetic energy equal to half mv square, that is half into 2 into v square, that is 5 square, that is 25 at joule, that is 25 joule. It is the kinetic energy of the body. So in this, from this context, some math has already explained in you, and I explained that work energy theorem for a variable force, and what is potential energy, relation between kinetic energy and linear momentum. Now linear momentum, what is linear momentum? Linear momentum is mass into velocity. So m into v, that is p, momentum. Now kinetic energy ke, that is E, equal to half mv square. So if we express this by the term of p, mv square, that is we have m square v square by m, that is mv square, m square v square by m, that is mv square, and half. Now m square v square, that is p square equal to m square v square. So half p square by m. So if we cross multiply, that is p square equal to 2me. This is the relation. So p equal to root over of 2me. So momentum equal to root over of 2m, 2 into mass into kinetic energy. This is an important relation. In this chapter also, law of conservation of mechanical energy, equilibrium, law of conservation of energy, Newton's law of collision, and power, concept of power, and elastic, inelastic collision, what is perfectly elastic, what is perfectly inelastic collision. Those concepts are also in this chapter. I try to explain in the next video of that portion of from this chapter. Follow this video, and I will try to give my best to explain all the portions from basic science and engineering portion, and which is also the subject of physics. So thanking you